So this subject has two parts: pavement, materials and design. So we will learn about the materials and also we are learning about the design. So this tutorial has only 4 questions, very simple 4 questions. So I will summarize, or else I will give you an overview of the subject as well at the beginning so that you will be able to answer the 4 questions easily. So there are 2 parts: material design part and the structural design part. I hope you know this. So as I have mentioned, there are 10 modules altogether. In the first module, which your tutorial questions are on first module, that is just the introduction to the subject. And from module 2 to 6, you will learn about the materials. So the material design part, because most of the materials that we are using in pavement design are natural or industry byproducts. For example, aggregates. They are coming by like breaking rocks, isn't it? So rock formation, we can't control it. So it's a natural material. Particle size distribution, again, we need to select the right particle size distribution. We need to check the materials, for example, permeability. We have a question today to find the porosity. So evaluating materials is very important because they are natural materials. We should be able to test it and find the properties so that we can use the right material for a given application. And again, we will learn about the asphalt mix design and concrete mix design. So that means not only selecting the right material, we need to know from each material how much we need for a mix, concrete mix or an asphalt mix. So we will learn how to do that as well. So that covers the week 2 or else the module 2 to 6, and module 7 to 9 is structural design part. So we will learn how to select which materials to go in different layers and how much thickness should have in different layers. Okay, so that structural design part we will do at the later half. And that there are two types of pavements, flexible and rigid. The structural design part is different to two of them. So we will learn both the pavements, how to do the structural design for flexible pavement and also the rigid pavements. And the module 10 is on maintenance. So you will learn about how to maintain, how to do the maintenance for flexible pavement and also for the rigid pavements. Okay, so in the module 1, these are the things that you have covered. Am I right? So you learned about the pavement types and components, structural and functional requirements of the pavement components. What are the 2 pavement types? What are the pavement types? Rigid and flexible. And the components, what do we mean by components? Different layers. We have questions, we are going to learn about it. Structural requirements and functional requirements. What do we mean by those 2? Structural part is your pavement layers should be designed in a way it should be able to withstand the loads coming onto that without any deformation, without cracking. So that part is the structural requirements. Volume, stability, the propensity to crack, or else the strength, they all comes under the structural requirements. What do we mean by functional requirements? Function? Yes, functional requirements are only for the top surface because we don't see the other layers. Functional requirements are for us to give a smooth driving experience when we are driving on the road. So what are the functional requirements? When you drive, what you expect? Yes, the right roughness. It should not be too smooth, then you slip on the road. It should not be too rough. If it is too rough, it will be noisy, and also it is consuming a lot of energy and fuel, isn't it? What else? Noise, dust, the aesthetic, you would like to see it nice, isn't it? So they all comes under the functional. They are not affecting the structural part of the pavement, but they are also needed. Design parameters, we will learn, you have discussed those as well. 5 classes of pavement materials. Have you done that in the lecture? What are the 5 classes of materials? In any layer, these one of these will go. So one is the asphalt concrete, am I right? And the next one is the cement concrete. And what else? You can have aggregates, granular aggregates, aggregates like, as they are, aggregates, and also you can have modified aggregates, and you can have cemented aggregates. So these are the 5 classes. Are you guys in the lecture week 1? Have you heard of this stuff? So you are still at the very beginning. Please, you have MCQ questions as well. So it's not only the numerical questions. It's very important to know the theory. So attend the lectures and follow from the beginning. Otherwise, it will be too much for you to study during, everything at once. And then 6 key phases of the pavement life cycle, distress modes of the pavements, and factors and characteristics that need to be considered in material design. So these parts were covered in your lecture 1. If you are not sure about this, or if you have forgotten this, please, when you go back home, go through this. Because within 1 hour, we won't be able to cover all this stuff. Okay, so what is a pavement? Pavement is the road, but if you search in Google, it says the hard surface. So that is the definition. Hard surface or the road surface that is installed for the sake of sustained vehicles and foot traffic. So these are the 2 types of the pavements. So just by looking at them, you can figure out which one is what. Which one is what? Yes, one is flexible. Which one is the flexible pavement? Yes, so this one is the flexible pavement, and this one is the rigid pavement. So now you know when you go on the road, you know which one is what. What is the main difference between these 2?
Integrity.
Yeah. Integrity. Okay. The main difference that when you see it, you can find it. You can say what is the difference. So in both we have aggregates, but to bond the aggregates in flexible pavement, we use the binder as the bitumen, isn't it? To bind the aggregates in the rigid pavement, we use cement and water as the binder. So main difference is the binder. So we have bitumen in the flexible pavement, and we have cement in the rigid pavement. And the next thing is their pavement components are also different. So if you go to next, you can see the main difference is the binder. Next is the pavement layer. So you can see we build the road on top of the native soil, which we call the subgrade. Am I right? On top of the subgrade, we have the subbase, and then we have the base. And in the flexible pavement, we have a varying surface as well. So when they ask you to draw in a question, if you have to draw the pavement components, you should be able to draw these 2, one for flexible and one for rigid. And what else? What are the other changes, other differences between flexible and rigid pavements? There are a lot of differences, but for us, to do the design part, next important difference is the way the load distributed. So as you see here in the flexible pavement, load is distributed just below the tires. But in rigid pavements, the load is distributed by bending. It's like a beam. Why we need to know this? To do the calculations and find the right material and to find out the right thicknesses, we need to know how the load is distributed, isn't it? So we are going to use this knowledge as well when we do the design part. And also, if you look at the maintenance, rigid pavements are with less maintenance, but flexible pavements are with more maintenance. But construction cost is higher in the rigid pavement, but less in the flexible pavement. Durability, more durable. The concrete pavements are more durable. Flexible pavements are less durable. So there are other differences as well. So you can go through your lecture notes and you will find all the differences. Any question? No questions? Okay, so there are a few things that we need to know to design a pavement and also to select materials. First thing is we need to know the subgrade characteristics. Subgrade is our native soil, so we need to know the CBR value. Have you done this soil? So you should have, you don't need anything from soil, but like, you know, we need to know about the CBR. We need to have this California bearing ratio of the soil that we are going to build the pavement. And also we need to know the vehicle characteristics. We only consider the heavy vehicles for the structural design part. We don't need the volume of light vehicles for structural design, but if you do the geometric design to find out number of lanes and all, you need to know the light vehicles. But for us, in this subject, we only look at the heavy vehicles. Do you know the difference between heavy vehicles and light vehicles? Good. And it's not the kilonewton value. We need to know the tire configuration as well, whether it is a 2-axle, whether it is a tri-axle, how many number of tires in 1 axle. So we need to know those stuff as well, because we know the load distribution will be different depending on how the tires are in a vehicle. Am I right? So we need to know all that, and also we need to know the design speed, and also we need to know the environmental characteristics. If we are building here in Sydney, the temperature and the moisture will be different. But if we are building in Canada or maybe Hobart, Gosford, wherever it is, depending on where we are building it, environmental conditions, so the temperature will be different. So we need to know that as well. The other thing that we need to know is which part of the road that we are designing. Free-flowing part or a roundabout, T-junction, they're all important. You will learn all this in coming weeks, and this will be a very important and interesting subject, because when you look around, you will see the application of this. So that's the basic things that you have done. The tutorial question. Do you guys have any question up to here? Okay, so you are 100% okay with the theory. At least if you fail to go back and go through the lecture notes, that's good. Okay, so can you try to do this question, because in the tutorial I'll just help you and you will be working on the tutorial questions, but I can help you if you have anything to get clarified. This experimental setup is for us to find the porosity of a material. What do we mean by the porosity? What is porosity? You need to actively participate, otherwise I have to collect your tutorial answers to give the marks. So if you all are actively participate, I just use the attendance sheet and will mark you guys. Otherwise, what do we mean by porosity? Permeability, both the same. What's that? Yes. So how easily water can flow through a material. So porosity is very important. So this experiment is for us to find the porosity of a material. So we put a porous material in this cylinder here, and we let the water to flow. We create a pressure difference, so the water will flow from this side to the other side. By finding how fast this water flowing, or finding the flow rate, we will be able to find the porosity. Am I right? So they have given us a few information. In the laboratory, the permeability of granular material can be measured as in the following diagram. The material specimen of uniform cross-section is enclosed by 2 walls and is then subjected to a small difference in the water pressure. And they are saying the length of the specimen, that means this length is given to us, and the diameter of the cylinder also given to us. This is a cylindrical part. The constant head difference also given to us, h given to us. Volume of the water collected in 5 minutes. In 5 minutes, 0.3 liters are collected from this side. So they have given you everything, and also they have given you the equation to find the permeability. Okay, coefficient of permeability. You just have to put the numbers in this equation and find the answer. Okay, but you have to look at the units. So we have centimeters, liters, minutes. You don't have to convert everything to the SI units, but like, you can't keep liters and centimeters. You may need to convert liters to centimeter cubes. And then you can have your answer in centimeters per minute. It doesn't matter. If you want to convert it to SI units, you can do it. Otherwise, you can leave everything except the liters, because liters you need to convert it to centimeter cubes. Otherwise, it won't the units will be different. So I'll give you a few minutes for you to try this, and then I will do by myself. If you have any question, you can ask. Did you find the Q? So Q is 0.3 liters per 5 minutes. Okay, so you can convert the minutes to seconds, but you don't have to. Okay, as long as you put the right units at the end, you can keep the units. However, liters, you can't keep liters and centimeters both. You have to either convert centimeters to, you can't do that, but you can convert the liters to centimeter cubes, isn't it? It will be easier then. Everything will be in centimeters. So how do you convert this liters to centimeter cubes? 1000 centimeter cubes are in a liter. All right. So we times by 1000 and we divide by 5 minutes. So we get the flow rate 60 centimeter cubes per minute. If you have done it in meters and seconds, that will be different. But as long as your method is right, it should be okay. Did you get this? Did you get it or not? That's fine. That means you need to divide. Then it will be 1 centimeter cubes per second, isn't it? Yeah, that's right. If you made it minutes to second, that will be 1 centimeter cubes per second. That's also right. Okay, now we need to find the cross section area. It's a cylinder, so circular cross section area. How do we find it? Pi r squared or pi d squared over 4, isn't it? So when you put that in the equation, I got 12.56 centimeters squared. If you made it to meter squared, that will be different. But something like, do you get this? Now when you put all the numbers in the equation, you get the K. So what do you get for K?
The radius says 4.
Radius is not the 4. 4 is your 4. 4 is the diameter. Yes. Yes, I have halved it. Yes, 4 divided by 2. So 1.6 centimeters per minute. But if you made it to seconds, I have to divide by 60 to make it to seconds. And if you make it to meters, then I have to divide again by 1000, isn't it? You get a very small number. 2 point something times 10 to the negative 4. Are we good? Any question? No question? Can I move to the next one? Okay, next question. I already told you this at the very beginning. The major components of flexible pavement and the rigid pavement structure. Please, can you draw it, please? What are the purpose of the base in the pavement structure? So I'll give you a few minutes again for you to do this one. I already showed you that what is the difference between flexible and rigid pavement. Just one layer, isn't it? Flexible has a wearing course, but the rigid doesn't have. That's all. So can you please draw it? Have you done the part 1? So these are the structures, the 2 structures, am I right? So subgrade is your native soil. What do we mean by DSL? That's your design subgrade level. So you don't have to write it, okay? You can have subgrade, subbase, base and wearing course. So do you have that 4 layers? And in the rigid pavement, you need to have subgrade, subbase and the concrete base. These are the basic things. And like, later on we will learn, we can have, you can have combination of these 2 as well. On top of the concrete, you can have a asphalt layer to get the functional requirements. So these two are the basic for you to start learning about the road design. Okay, so so they all have some purposes, or they all are having some job to do. So you have this in your lecture notes in detail. Am I right? Okay, do we have any question regarding these layers? So natural soil is your subgrade. Subbase is the main component which holds the load, and base is hold the load and distribute to the subbase, and the bearing surface is it should be user friendly and safe to drive. And also all layers should have structural requirements, but the bearing course should have functional requirements as well. Okay. And the next part of the question number 2 is asking, what are the purposes of base in pavement structure? So what are the purposes of base? Every layer has a purpose, and you have the purpose of each of the layers. Every layer in a table, you have it in your lecture notes. So for the base, what are the purposes of the base? Yes, that's right. If you consider an engineering vocabulary, what can you say? It should be deformation. If I say one example, deformation resistance. So it should keep the shape. Am I right? So to keep the shape, or it should provide volume stability, or else volume stability for smooth riding surface, minimize the ingression of moisture, minimize change in the strength with the time, provide shear strength and cohesion. So these are the purposes of the base. So base is providing a shear strength and cohesion, minimize the changes in strength with time, minimize the ingression of moisture, have volume stability for smooth riding surface. Volume stability means keeping the shape without sagging, without changing it. Are we good? So your quizzes and the final exam, everything has MCQ questions. So it's very important to know the theory as well, not just the numerical part of it. Question number 3, what structural and functional requirements should be considered for pavement bearing surface? Can you write this, answer this as you remember? I told you a bit about it at the very beginning. Functional means what? Structural means what? Am I right? Structural requirements are deformation resistance, durability. Deformation resistance is not to deform. Durability is long lasting, strength, propensity to crack are the structural requirements. And the functional requirements are the right roughness. You need to have the right roughness, otherwise you will slip on the road. Skid resistance, surface texture, surface drainage characteristics. Water should not pond on the road. It should drain to the drainage. Noise characteristics and the aesthetics. It should look nice as well. So these are functional requirements. The top 3 are the structural requirements. And also you have a table for this, for all the layers. In your lecture notes you can see that. Am I right? Okay. Last question. Every tutorial is not like this, okay? So we have very simple 4 questions for today, but from next week we have a lot of numerical questions. It will take time. Okay, what are the benefits of reusing or recycled materials? List some of the major industry byproducts that are used for pavement materials. We need a lot of materials for road construction because it's many kilometers, isn't it? So we need a lot of aggregates. For getting the aggregates, we need to break rocks, and it is a lot of like, energy consuming process, isn't it? Even the cement. So they, like, especially mainly when you consider aggregates, if we can have some byproducts, industry byproducts, OLs, any recycled materials as aggregates, we can save energy, we can save cost, and also we can prevent dumping to landfill. So there are a lot of advantages. So can you please answer this question as you understand, and I will go through the answer after you try by yourself. So what are the benefits? Energy saving, reduce the disposal to land sites, protect natural resources, protect the environment from further degradation, cost savings, ecological sustainable development. Am I right? Are these right?
Yes, yes.
Okay. And what industry byproducts? Slag products, coal combustion products, recycled building materials, recycled rubber products, recycled asphalt products. We can use them as industry byproducts. So we can reduce the materials that we are taking from the earth. Am I right? Yes. Okay, so that's the end of our 4 questions. As I have told you before, every tutorial is not like this, okay? So we have more numerical questions from next week, aggregates. So it will take time. Yeah, so if you have any question, we can discuss. Otherwise, yeah, that's all for this week.